Hello friends, in this video I am going to discuss about minors and cofactors of n determinants. That what is minor of a determinants and its cofactor, what is adjoint of a determinants. In the previous session or in the chapter matrix only, I am discussed about how we find the inverse of a matrix. In this chapter, in determinants, we find that whether the inverse of a matrix exists or not, or if it exists, what is its inverse. We have to find this actually, and for that we have a need of adjoint of a matrix, because we can find determinants by the help of adjoint only. So how to find adjoints, I am going to telling you. So first is minor. What is minor of a determinants? Minor of a determinant is actually a determinant which is obtained by deleting that ith row and jth column and solving the determinants. What I am trying to say is that minor of an any element is defined as the determinant which obtained by deleting that ith row and jth column and evaluating that. So if we get suppose there is a determinant a, B, C, D, E, F, G, H, I. Suppose this is a determinant. So what is the minor of E? Minor of E. अगर हमें find करना है. In this we have taken any element. Suppose what is the minor of A, I, H. So here I am going to take about the minor of E. So what is its minor? I have said that minor is the value of the determinants which is obtained by deleting that ith row and jth column. What is ith and jth column? Suppose this is the element E. It is light on second row and second column. So what is I is second and J is also second. So hide that ith row, hide that jth column. What we get matrix A, G, C, I. What we get A, G, C, I. Solve this matrix. What we get AI minus CG. This is the value of minor of E. Means deleting that rows and deleting that column and we get the determinant. Solving the determinants we get the minor of E. Here the variables are given, but in the form of numbers we can easily find the minor of E. So this is the minor. So minor of an element Aij. So minor of an element, minor of element Aij is obtained by deleting that ith row and jth column, obtaining the determinants, and evaluating the determinants we can easily get the minor. Let's take questions. So let's take a question how we find the minor of an element. Suppose the determinant is given 1, 2, 3, 4, 5, 2, 5, 1, 6 of order 3 cross T. What is the minor of 5 and 6? 5 और 6 का minor क्या होगा? Or it is also written in the form of M. What is the minor of M22 and what is M33? It can be also written in the form of M22 and M33. Means second column, second row में जो element होगा उसका minor क्या है, और third row में और third column में कौन सा element है उसका minor क्या है. So by deleting that ith row and jth column we obtain a matrix 6 1s are 6 and 5 3s are 15. What we obtain? We obtain the matrix 1 3 5 6. Solving that matrix 6 1s are 6, 5 3s are 15. We get 9, minus of 9. This is the minor of M22. So and what is the minor of M33? Hiding the ith row and jth column. What we obtain? We obtain a matrix. So M33 equal to, we obtain a matrix 1 2. We obtain a matrix 1 2 2 and 5. 1 2 2 and 5. Hiding that ith row and jth column. Solving that determinant we get the value 1, and this is the minor M33. So what is the minor? Minor of any element Aij is denoted as Mij and it is obtained by solving a determinant which is obtained by deleting that ith row and jth columns. This is the concept of minor. And what is cofactor? Cofactor is nothing but multiplying the minor with its position sign. What do you mean position sign? कौन से position पे वो lie कर रहा है उसके साइन से मल्टीप्लाई कर देंगे अगर हम माइनर को, उसी माइनर को, देन वी गेट कोफैक्टर. सपोज द माइनर ऑफ दिस 5 इज -9. सो व्हाट इज इट? कोफैक्टर ऑफ 5 मल्टीप्लाइंग दिस विद साइन. बट वो साइन कहाँ से आएगा? वी फाइंड द साइन बाय एडिंग दैट ith एंड jth इफ इट इज ऑड. अगर ये ऑड रहेगा और अगर ये इवन रहेगा. अगर हम फाइंड करते हैं सम ऑफ i and j, if it is odd, then अगर ये हमारा odd है so we multiply by negative sign. If it is even, then we multiply it with its positive sign. So we know that m is lying on second rows and second columns, means its position is 2 2. Then adding that 2 plus 2 we get 4. This is even, so we can multiply positive sign. So the cofactor is denoted as A, capital A. Capital A 2 2 is written as positive multiply करेंगे, positive multiply anything is nothing. So positive multiply करेंगे that -9. If we get 3, if we find the minor of M33, cofactor of 6 means it is lying at third row and third columns. So what is sum of 3 plus 3? It is equal to 6, which is even. So we multiply only positive sign. Positive sign multiply करेंगे तो हमें सिर्फ 1 ही मिलेगा. So this is the cofactor of 3 3. So what is cofactor? Cofactor, अब हमारा cofactor क्या होता है? Cofactor is nothing but multiplying its minor with its position sign, or it is denoted by capital Aij. ये हमें obtained होता है by multiplying I plus j. अगर ये odd है by multiplying 1 minus 1 with I plus j. If it is even, then it becomes positive by multiplying with minor I of ij. So cofactor is nothing but multiplication of its minor with its positive or negative sign, and that we have find if we know the rows and columns by adding their sums or taking their sums. If the value is even, then it becomes positive, and if the value of then cofactor become equal to minor, or if the value become negative, then cofactor is nothing but it's just negative of minors. So in this way we have find the minor and the cofactor of elements. Suppose we have to find the minor of A12. A12 means first row and second column. This is A12 and we have to find this minor. So minor of A12 is what? Deleting that first rows and second columns, we get the determinants 2 3 1 6. Solve this. 6 to the 12 and 3 ones are 3. The 12 minus 3 we get 9. This is 9. What is its position? Or what is cofactor of A12? -1. 1 plus 2 with minor. -1 plus यहाँ 3 हो जाएगा. So -1 to the power 3, power is odd. So what we get? Minus sign, -9. So this is the cofactor of A12 and this is the minor of A12. So now we have proved that what is minor and cofactor. Now I am going to tell you one thing, that or one concept behind this, that if the cofactor of any row or column is multiplied with any other row or column, then the value of the determinant is equal to 0. Means suppose that this is the determinants. Suppose this is the determinants, and if the cofactor of any rows, suppose 2 1 या हमने ले लिया 1 2 whatever, if the cofactor of any rows or column multiplied with rows and column of any other rows or column, then the value is equal to 0. Means A12 plus A. So what we have seen here, that if the cofactor of any rows or columns get multiplied with any other element of any other rows or column, then the value of the determinant is equal to 0. This is the expression that if the cofactor of any rows or column get multiplied with elements of any other rows, then the value of the determinant is 0. Or if it is multiplied with the same element, then it is equal to mod of A, means the determinant of A. This is the two concept behind this about minor and the cofactors, which we have proved here. So in this video I have discussed about minor. What is minor? Minor is nothing but a determinant which is obtained by deleting the ith row and jth column. Then we have to solve this value, then we have to solve the determinants, we get a value. This is a minor. It is denoted by Mij. And what is cofactor? Cofactor is nothing but multiplication of its minor with the sign of its elements. Suppose it is lying at position first column and second rows, A1, 2. So adding that I and j, what we get? 3. 3 is odd, so negative sign is there. So if the sum of rows and columns at what position the element is lying is odd, then cofactor is negative of its minor. But if it is even, then cofactor is equal to minor, because positive sign has no meaning. And the next thing we have discussed is about that if cofactor of any element or rows is multiplied with element of any other rows or column, then the value of the determinant is, then the value or the expression is equal to 0. And if it is multiplied with same element, then it is equal to determinants of A only. Okay. Let's discuss what is adjoint of a matrix. Adjoint of a matrix. What is adjoint of a matrix? Adjoint of a matrix is the transpose of all the elements of a determinants where element is capital Aij. What is the meaning of this? Means cofactor. अगर elements cofactor हैं उस elements के, then the transpose of that cofactor is the adjoint of a matrix. Suppose determinant is given A, which is x, y, z, x, y, mn of order 2 cross 2, then what is its adjoint? So first we have to find the cofactor of that. What is its cofactor? And we know how we find the cofactor by multiplying the sign with the minor. What is the minor of x? It is n. 1 plus 1 is 2, which is even, so positive sign is there. What is the cofactor of y? M. 1 plus 2 is 3. 3 is so odd, so minus sign is there. What is A21? 2 and 1, y. 2 plus 1 is 3, so negative sign is there. A22, then x, and 2 plus 2 is 4, so positive sign is here. So A11 is equal to n, A12 is m minus m, A21 is minus y, and A22 is positive x. These are the cofactors of that determinant. So what is cofactor अगर हम पता करें, so what is adjoint of that? A. Adjoint of A is transpose of its cofactor. Transpose of its cofactor means, what is cofactor? A11, that is n minus m minus y x का transpose लेंगे and we get n minus y minus m and x. This is the adjoint of A. So what is adjoint of A? Adjoint of A is nothing but the transpose of all the cofactor of that elements. We have first taken out the cofactor, put in the determinants and taken its transpose, we get adjoint of A. And if you look these two things, what you have seen here, that x get replaced with n and n get replaced with x, means their position get changed. So n ऊपर आ गया है, this is actually n, और x यहाँ पे है, और m और y में the difference is only of negative sign, that these two are multiplied with negative sign. So if any determinant is given 1, 2, 3, 4, so it's adjoint of A. We can simplify it without doing much calculation, that 2, 1, minus 3, minus 4. means exchange these two things and take the negative of these things. So we can easily find the adjoint of A. So you know what is adjoint of A? Adjoint of A is nothing but the transpose of all the cofactors of the elements which we obtained. If it is 2 cross 2 matrix, so we can easily find the adjoint by reversing that diagonal matrix के element को reverse कर देंगे and multiplying minus sign with their signs. Okay, understood? Now let's see what is singular matrix and what is non-singular matrix. In this video, I'm discuss about what is minor, what is cofactors, and what is the adjoint of a matrix, and how we find the adjoint. Now let us discuss what is singular matrix and what is non-singular matrix. So singular matrix means if mod not determinant of A is equal to 0, it is singular matrix, and if determinant of A is not equal to 0, then it is non-singular matrix. Suppose A is a matrix 2, 3, 3, 2. Suppose this is the matrix of order 2 cross 2. Mod of A is 3 2s are 6, 2 3s are 6, which is equal to 0. So we can say that A is singular matrix. तब हमारा जो A होगा वो singular matrix होगा. और if A is given as 5 4 3 2 means mod of A is equal to mod of A is equal to 5 2s are mod of A is what? 5 2s are 10 minus 4 3s are 12. 10 minus 12 which we get minus 2. So mod of A is minus 2 means A is non-singular. So A जो होगा वो non-singular होगा और यहाँ पे जो A है वो singular matrix है. So we have discussed that if the value of the determinant becomes 0, then A is singular matrix, or if the value of the determinant is not equal to 0, then it is known as non-singular matrix. This thing we have shown that what is singular matrix and what is a non-singular matrix. This is basically used in the concept of finding the equations or finding the values of the variables when equations are given, that whether the equation is consistent or inconsistent. In that case, we have used a concept of singular matrix and non-singular matrix. Here I am just give you the feel that what is singular matrix and what is non-singular matrix. The matrix is non-singular. We simply write that it is consistent and it has no solution, means unique solution exists करेगा, only single one. And if it is singular, means mod of A is equal to 0, then there is a condition, a further condition is also there, that if adjoint of A multiplied with B is equal to 0 or not. So this thing we have discussed, जो हम equation find करेंगे or the equation whether it is consistent or not consistent, in that case we use this concept. अगर matrix non-singular matrix है, so what we have done, we have simply say that the equation or line is consistent, having unique solution. Or if it is singular matrix, then further condition is also there, that whether adjoint of A multiplied with B is equal to 0 or not. So this thing we have discussed, आगे discuss करेंगे. Here we have discussed only singular and non-singular matrix. Now there are some formulas related adjoint and the determinants. कुछ formulas हैं related to adjoint and determinants of a matrix or determinants. So first is that A into adjoint of A or adjoint of A into A is equal to mod of A, not mod, determinants of A dot I. What is I? I is identity matrix. So it is first formula that A into adjoint of A, or its position can be translated adjoint of A into A is equal to mod of A into I. Mod of A or I के equal होगा. If suppose it is given that A into adjoint of A is equal to 8 0 0 0 8 0 0 0 8. So what is the value of mod of A or determinant of A? So we simply take 8 common. 8 common लेंगे तो क्या बन जाएगा? 1 1 1 and this is the identity matrix. Or what is the value of determinant? Value of determinant is 8. So it is used in conceptual questions that whether this equation is given and we have to find the determinant of A, we can easily see the determinants and find the value. Second one is that determinant of adjoint of A is equal to determinant n minus 1. Now here you are, what is n? You are thinking what is n? So n is nothing but the order of determinant. n जो होगा वो सिर्फ order of determinants है. That what is n? n is the order of determinants. So the determinant of adjoint of A, that if adjoint is given, so what is its determinants? It is nothing but mod of A n minus 1, where n is the order of the determinant. Suppose there is a determinant of order 3 cross 3 and we have taken its adjoint. So now we have to find the determinant of adjoint, its value. So we simply take determinants to the raised to the power n minus 1, 3 minus 1, that is A square. Determinants of A square. So in this way we can easily find the determinant of adjoint of A. And the last thing which I want to tell you, that how to find the inverse of determinant or matrix. We know how to find the adjoint. In this video I am telling you about that how to find the adjoint of determinants. It is simply multiplying the minor with its sign of rows and columns, adding rows and columns. If it is odd, the negative sign get multiplied, or if it is even, then positive sign is there. So how to find, if it is given that AB equal to BA, which is equal to I, so B is inverse of A, or can be written as A inverse. So how to find that values? We can easily find the inverse of a matrix. It is given as 1 by determinant and adjoint of A. In this way we can easily find the inverse of our determinants, or A inverse. If AB equal to BA equal to I means identity matrix, so we can say that B is the inverse of A, or A inverse. And how to find the value of B inverse? We can easily use this concept, 1 by mod determinant of A multiplied with adjoint of A. So this is all about the formulas and relations between the determinants and adjoint of a matrix.